Welcome back to C++ with Miyoshi. Today we're going to talk a little bit more about constants and variables, or identifiers, and I just wanted to talk to you a little bit about a couple different things, outputting and this little thing called pound define. Now, if you look online, and you should probably look online to see other people's code, you'll see the pound define sometimes, and here I have pound define SAM 14.3, and what that does is not really a constant, but it kind of acts like a constant every once in a while, or people use it as constants. What it does is it takes that SAM, and everywhere it sees SAM in my, oops, that's why I added 14, SAM in my code here, it's going to replace SAM by 14. So it's not really a constant, it's just a what's called a compiler directive. So that compiler directive says SAM is going to be 14 there. Okay, as we go forward, I will not be putting all these pound defines in the int main all the time. I try to match my curly braces, but I won't use all these conventions in there every time because I just want to show you the relevant code. But here we go. And if you see these little dots, they mean that there's other code inside there. For instance, in this particular code, the dots mean that I gave values to f and some of these other guys in here. Okay, so I have an int, a float, or a few floats. Notice on this line here, I have float div is assigned the value 3.1, comma b, comma d is assigned the value SAM, semicolon. This shows that I can declare more than one variable on a line, and I can even declare and initialize something on a line with something that's not initialized as well. As long as they are the same data type, I can do that. Well, they will be the same data type when I do that. I have a double Q13, a long f, and a char ants, and I gave it a value of single quote n. This is really to show you that when I assign the value to a character, it's going to be in single quotes. If you put it in double quotes, it's not going to like it. It's actually going to, the compiler is going to yell at you and tell you that doesn't work that way. Here we have printf. These guys here, all they're really doing is telling you that the way you output data. Now, if you're using cins, you don't have to worry about this, or cins and couts, you don't have to worry about that so much. It takes care of it regardless of the data type. I like printfs because I can do a few things here. This guy looks exactly like I'm going to see it. It does double quote, %i backslash n double quote, comma a. Well, the %i says save space for an integer. And so this guy over here must be an integer. So a we know is an integer. So this guy here is going to output my SAM, which is going to be the 14. The reason I like this is I might even put in a 3 in front of that, %3i, and that now will save spaces for 3 spaces for my integer. So however big it happens to be, if it's only one digit, then it'll save 2 spaces in front of there for my integer a. The %c, that says it's a character, and so it's going to output my character n. My %e, here's a, well actually let's skip that one for a moment. I have here printf %lf backslash n %li backslash n %f backslash n double quote. What this does, it's kind of nice. It shows you that this is kind of what you see is what you get, a little bit of WYSIWYG. It's going to print a float, a long float, which is a double. An LF just means a double, and print a new line that's going to print an LI, which is a long. So I have a long here, F. Then it's going to have a space for a float and a new line as well. So this guy here, the LF must match that guy. So the Q13 better be a double, which it is. The LI better be a float, or a long, which F is a long. And the F must be a float, so my D has to be a float. And indeed it is, wherever it is. There it is. Okay? Some things my students have done in the past is they sometimes will put % and whatever the variable name is. And notice here that these guys can only be certain things. It won't give you an error, a compile error, but it will give you some funky answers when you output that guy. So make sure that you're putting in the correct placeholder there for your variables. Here is one more thing. It shows you that I can put anything in my double quotes, in my literal, if you will, and this saves my space for the character. In this case, your answer is %c, and in this case, it's going to be the no is going to go in there, and then that's going to print out the rest of that line there. The %C matches the ints after the comma, and again, that's the same kind of thing here. All these guys, the comma is separated out, separates out the what's inside my literal with my variable. Now the one that I skipped over, the printf %e \n double quote comma div. In this case, my e, all that means is output this guy, whatever type of variable it is, and it could be any type of variable, any numerical type of variable. It's going to print it out, div in this case, as a scientific notation. So the E just means we're going to do it in scientific notation, and that looks something like this. Over here, if you remember one of the last ones I did, I have const float, C is assigned the value 3E8. Well, what does that really mean? Well, that says it's a constant. CONST means it's a constant. It's a float, and C is going to be the value 3E8. Well, what does that 3E8 really mean? What it means is the E stands for times 10 to the power. So in this case, it's 3 times 10 to the power 8. So if we look at it, 3E8 is equivalent to 3 times 10 to the 8. Now, I don't know if it's self-fulfilling prophecy or just people don't listen well or what it happens to be, but always, 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 I get somebody who, even though I tell them that this is not correct, I still get students doing const float C is assigned the value 3 times 10E8. Well, this will give you a value that's 10 times too big because it's doing 10 times 10 to the 8th and multiplying that by 3. So in this case, the speed of light would be 10 times faster than it really is in real life. So make sure you don't do that. Okay? So again, the E stands for times 10 to the power. So if I want 3 times 10 to the 8th, I want to do 3E8. That's about it. Now, one other thing is if you want, there's tons and tons of things you can do with the printf format specifications. If I want to have a float that has so many decimal places after it, I can do percent 3.1 f, and that will give me 3 spaces with 1 decimal place after it for a float. But look up printf format specifications and you can see all kinds of cool things you can do with the printf function. So hopefully you are getting a little bit of the hang of programming C++, and hopefully tune back again next time.